Okay, so there's this buzz in the air, right? A kind of persistent hum about AI agents. You hear they're promising to transform basically everything from customer service all the way to coding. You've probably seen the headlines, heard the big claims AI that doesn't just respond, but actually thinks, acts, and automates, making 2025 the year of the AI agent. It feels like, you can't open a news feed without seeing another story about how these autonomous systems are set to just revolutionize everything. The optimism is, well, it's genuinely infectious. It paints this picture of a future where all the boring tasks just vanish, handled seamlessly by intelligent machines working 24/7. But, I mean, how much of that is actually reality right now and how much is just, well, pure hype? Our mission today in this deep dive is to try and cut through that noise. We've pulled together a stack of sorted articles, some cutting-edge research, expert analyses, basically, to uncover the truth about where AI agents truly stand. What are their surprising limitations? And maybe most importantly, where are they actually making a genuine difference today?
We want to go beyond those like flashy lab demos and really understand the mechanics underneath and the gritty operational realities that, frankly, often get glossed over. You might be wondering, though, what exactly are we talking about when we say AI agent? How's it different from, say, the chatbots you chat with online every day?
Yeah, that's a really crucial question because the term AI agent itself, it gets misconstrued a lot, and honestly, that misunderstanding fuels a good deal of the hype we're seeing. Think of it like this. A simple chatbot is kind of like a highly trained parrot, right? It responds to your prompt, maybe follows a pre-programmed script. It's reactive. An AI agent, though, is designed for something way more ambitious. It's meant to perceive its environment, see what's going on, then reason about those perceptions, think about it, and crucially, take independent action to achieve some predefined high-level goal. And ideally, with minimal human intervention, you can picture it as a continuous loop. Perception, reasoning, action, always aiming for the best outcome. That's what really sets it apart from, traditional bots or even basic AI assistants that just maybe recommend something or give you information. An agent is proactive. It's goal-oriented. It can break down a big objective into smaller steps, figure out the best order to do them, and then actually execute those tasks by using different tools, maybe APIs, databases, web services, whatever it needs. It's really about making a whole series of informed decisions to get somewhere, not just answering one-off questions. And ideally, it learns and adapts along the way.
Right. Okay. And as we'll probably find out pretty quickly, that promise of independent action is exactly where, the rubber meets the road. And sometimes, well, the wheels just come right off. Our sources are showing this fundamental disconnect between those dazzling lab demos, which, let's be honest, are often super carefully curated and controlled, and the messy, unpredictable reality of actually deploying these things. And this isn't just about a few minor bugs here and there. We're talking about a pretty significant gap in fundamental capabilities, things that are absolutely crucial for real-world reliability and, importantly, safety. So yeah, let's dive in. Let's sort out the fact from the fiction. We should probably start with the grand promises, right? And then maybe get into the challenging truths that seem to follow. Okay, so let's start by looking at this incredible optimism swirling around AI agents. It's not just a whisper. It's more like a roaring declaration from some corners. Industry leaders are almost universally proclaiming 2025 is the year of the AI agent. And the market projections, they're just eye-popping.
Our sources are citing this explosive growth, jumping from maybe $5.1 billion, maybe $5.4 billion in 2024, to a staggering $47.1 billion, or potentially even over $50.3 billion by 2030. Now, for anyone less familiar with market jargon, that means a compound annual growth rate, a KGR, basically the average annual growth over time of somewhere around 44.8% to 45.8%. I mean, these aren't just big numbers. They suggest a really transformative, almost exponential shift in how businesses might operate, how tech integrates into our lives. It feels like it's way beyond just incremental improvements. And it's not just market analysts throwing these numbers around. Think about what some of the biggest names in tech are saying. Their words carry immense weight, right? They shape expectations for everyone, for you, for businesses, for the whole industry. You've got Sam Altman, CEO of OpenAI, obviously a key figure. He positioned 2025 as the breakthrough year, saying agents will work. He didn't just talk about it. He famously demoed that autonomous voice assistant ordering strawberries over the phone. It seems simple, but it's a powerful vision, right? AI acting directly for us, with almost no human needed.
Then Sundar Pichai, Google CEO, he echoed this, called 2025 critical for scaling their Gemini agent into a universal assistant, one that can understand the world and take independent action. Basically an omnipresent digital helper for, well, everything. And then there's Salesforce CEO Mark Benioff. He went even further, making this incredibly bold statement, Agent Force would be the only thing we're going to do at Salesforce, and claimed their agents could handle something like 83% of customer support queries independently. I mean, these are not small claims. These are major strategic declarations from companies at the forefront, signaling this massive pivot towards agents as their core focus.
Yeah, and the marketing language has really kind of converged around these truly transformative promises, painting this picture of agents that think multiple steps ahead, act on your behalf, deliver end-to-end automation. Stress. Companies are touting huge efficiency improvements, 30-50%, cost reductions up to 40% in customer acquisition, even promising 247 operations without any human intervention, effectively getting rid of night shifts or weekend support humans.
To give you a concrete example, there's this healthcare startup, Hippocratic AI. They're claiming their agents can outperform nurses at just $9 an hour versus a nurse's average of, $60.26 an hour. So this isn't just about saving a bit of money. It's about potentially reimagining how entire industries like healthcare or customer service could operate with vastly reduced human capital, faster, more consistent, always available services. The narrative is incredibly powerful. These agents aren't just tools. They're like intelligent, tireless collaborators set to fundamentally reshape the economy and bring about unprecedented productivity.
Well, yeah, and if we connect this to the bigger picture, it's a pattern we've seen before in tech, hasn't it? Immense promise followed by these, well, almost utopian claims. Yet underneath these really ambitious declarations, there's a much more complex reality that experienced researchers are pretty quick to point out. Rena Danilevsky, a research scientist at IBM, she kind of captures this skepticism. She says, it's quite a statement to make when we haven't even yet figured out ROI on LLM technology more generally.
Wow.
And that highlights a crucial point, doesn't it? If the foundational tech itself, the LLMs, are still looking for clear, proven returns, then the leap to fully autonomous, profit-generating agents is, well, it's a monumental one. And this leads to what some analysts are calling agent washing. It's this phenomenon where, basic chatbots or maybe simple automation tools, perhaps even old RPA systems, just get rebranded as AI agents to cash in on the hype, which understandably creates a lot of confusion about what really is an agent and what it can reliably do. Gartner's hype cycle, for those who follow it, has AI agents perched right at the peak of inflated expectations. That's where the sizzle is really blinding, but the steak hasn't quite hit the grill yet. They're telling us we're in the super early stage, which is basically analyst speak for the current buzz is like a sci-fi novel compared to the operational reality. And that's a crucial insight. It reminds us the market has often priced in this future of widespread, reliable automation, but the tech just isn't there yet, which creates this dangerous strategic misalignment for businesses, where they're essentially being sold the dream of transformation without the underlying foundational problems being properly solved.
Okay, so we've painted this pretty dazzling picture of the future. The projections are massive. The claims from the industry titans are, frankly, monumental. But is this future actually here, or even close? Our sources strongly suggest that when you stepped out of the controlled lab environment and into the messy, unpredictable real world, the picture changes dramatically. This is where that rubber hits the road, and yeah, sometimes the wheels just seem to fall off completely. It's not just about minor performance dips either. We're talking about a critical disconnect that makes widespread autonomous deployment incredibly challenging, maybe even impossible for many really important tasks right now.
And this raises that important question. If the promises are so grand, why the struggle? Why isn't it working perfectly? Well, the core issue, as our sources rigorously detail, boils down to reliability. There was a comprehensive 2024 study from Carnegie Mellon University. They analyzed AI agent performance on actual real-world office tasks. And it exposed a pretty harsh reality. Even the best system they tested, Google Gemini 2.5 Pro, failed a significant 61.7% of the tasks. And that figure actually includes partial completion, so it's not even like it failed completely every time, but still couldn't finish the job properly over 60% of the time. OpenAI's GPT-4o, another top model often touted for its capabilities, performed even worse. It failed an astonishing 91.4% of tasks.
Wow, 91.4% failure. That's staggering.
It is. I mean, put that into perspective. Imagine if your email only successfully sent, 9 out of 100 messages? Or your online bank app failed over 90% of the time you tried to transfer.
You just wouldn't use it.
Exactly. You wouldn't trust it for anything important. That's the kind of real-world performance gap we're seeing for even pretty common office tasks. And this problem, it compounds. It gets worse with complexity. Even seemingly simple AI workflows made up of multiple steps, where maybe each individual component boasts, say, 99% plus uptime, which sounds incredibly reliable on its own, right?
Yeah, 99% sounds great.
But the overall reliability for the whole workflow drops to only about 98.3%. Why? Because of what's called multiplicative error propagation. Each step introduces a chance of failure, and those chances multiply. DeepMind CEO Demis Hassabis warns that even a tiny 1% error rate, if it's compounded over, say, 5,000 steps in a complex process, makes the possibility of getting a correct final answer basically random.
Wow.
Yeah. To illustrate it differently, think about a 10-step process. Each component is 95% reliable. Sounds pretty good, right?
Still sounds okay.
But the overall success rate for that entire process plummets to only about 60%. It's like trying to cross 10 bridges in a row, and each bridge has a 5% chance of collapsing. Your odds of making it across all 10 safely drop dramatically with each bridge you cross. This multiplicative effect is a fundamental and honestly often underappreciated challenge. It makes deploying agents in multi-step critical workflows incredibly precarious. On top of that, agent behavior is often non-deterministic.
What does that mean exactly, non-deterministic?
It means the exact same input, the same prompt, can produce different outputs or lead the agent down totally different action paths on different runs. Now imagine trying to validate and test a system that behaves differently every single time you run it.
That sounds impossible.
It becomes extremely difficult. Yeah, you can't guarantee consistent, predictable outcomes. And for most business operations that demand consistency, auditability, that's a complete non-starter. Our sources also note that agents frequently get stuck in infinite loops. They just keep attempting a failed operation over and over, or maybe reprocessing a task that was already done. This isn't just inefficient. It wastes a ton of computational resources, drives up API costs, and risks corrupting data through duplicate or conflicting actions. There was even a Reddit user who reported an AutoGPT agent racking up over $100 in API calls just running for 8 hours straight, with basically nothing to show for it.
$100 for nothing. Ouch.
Exactly. And perhaps most dangerously, LLMs are inherently trained to sound confident. Always. So an agent can present a completely flawed plan or a totally hallucinated fact with the exact same degree of unwavering confidence as a correct one.
That seems really risky.
It is. It creates a significant risk of misplaced trust by human operators. They might approve a disastrous course of action just because the AI presented it so authoritatively. And critically, these systems often lack true self-verification. They don't know when they're wrong or when their reasoning has gone off track. They rely on external feedback or human intervention to get corrected. It's like having a brilliant but incredibly overconfident assistant who never, ever second-guesses themselves.
Okay, that's a pretty stark picture of agents just struggling with basic execution, getting stuck, running up bills. But what about the thinking part, the brain of these systems? The whole promise hinges on them being able to reason multiple steps ahead. Or are you just asking too much? Or is there some fundamental design flaw that limits this thinking ability even before they try to act?
Indeed. That's another major hurdle. While large language models, they show impressive reasoning capabilities on certain tasks, especially tasks that look a lot like stuff in their training data, that reasoning is often quite brittle. It breaks down easily under real-world complexity. Their planning ability degrades significantly as tasks get more complex. Studies are showing that for multi-step tasks in realistic settings, even the top agent frameworks succeed only about 30% of the time.
Only 30%. That's still pretty low for complex planning.
It is. They struggle profoundly with sophisticated multi-step reasoning, particularly when they face novel situations or uncertain environments that are different from what they were trained on. It's kind of like they're great at following a recipe they already know by heart. But put them in a kitchen with unfamiliar ingredients and no instructions, they'll likely struggle to put together a coherent meal. A core limitation here is their lack of true causal understanding and, frankly, common sense. Current agents are built on these massive pattern-matching statistical models, not genuine comprehension of cause and effect. This leads to what researchers call superficial reasoning, and it results in unpredictable failure modes where an agent might reason correctly in one situation but fail completely on a very similar one just because it doesn't truly grasp the underlying principles. And the hallucination epidemic, it remains largely unsolved. Factual error rates range from maybe 15% for the very best models up to much higher rates in specialized fields. Think about critical areas like clinical documentation. Even seemingly small hallucination rates of, say, 1.47% or emission rates of 3.45% become absolutely critical in life or death scenarios. Accuracy there is paramount. A tiny error could lead to a misdiagnosis.
Yeah, you can't afford errors there.
Exactly. And paradoxically, some of the really advanced models can even overthink. They expend excessive computational effort and time on tasks where a simple, straightforward solution exists. It indicates a lack of common sense judgment in just allocating cognitive resources, leading to inefficient, costly operations.
So their reasoning can be brittle. What about just keeping track of things, like a long conversation or a complex task? It really sounds like memory must be a significant hurdle if they're trying to manage complex goals over time.
Precisely. Robust memory and context management, they remain significant technical hurdles. They fundamentally limit what current AI agents can actually achieve over extended interactions or complex projects. At their core, you have to remember, large language models are stateless systems.
Stateless.
Meaning they have no built-in persistent memory of past interactions beyond their context window. This context window is essentially the agent's short-term memory. Think of it like the number of open tabs it can juggle in its brain at once. And it's typically limited to somewhere between, say, 4,000 to 32,000 tokens. Tokens are like tiny chunks of words or data. Now, while some cutting-edge research models are promising these huge windows, hundreds of thousands, even millions of tokens, practical limits often kick in much earlier, maybe around 32,000 to 64,000 tokens, just due to performance degrading.
So they just forget.
Effectively, yes. Imagine a customer service agent trying to handle a complex issue over dozens of messages. Unless you keep repeating the key facts, the AI might literally forget the initial problem you reported by the end of the conversation just because it ran out of tabs for that specific interaction. And there's this fundamental long-standing problem in AI called catastrophic forgetting.
Catastrophic forgetting. Sounds dramatic.
It kind of is. It's where learning new information tends to overwrite or interfere with prior knowledge. It hinders true lifelong learning and building up knowledge over time. It's like trying to learn French, only to find you've completely forgotten Spanish in the process. Now, efforts to integrate external long-term memory solutions, things like vector databases for semantic search, they've so far been described as, well, clumsy.
Yeah.
AutoGPT, for instance, initially included an optional vector memory to store facts between steps, but the development team found it rarely improved outcomes, and they actually removed it later.
Why remove it? Seems like a good idea.
Because the agent often didn't know when to retrieve from memory, or would hallucinate a search query to fetch something irrelevant. It just wasn't smart enough to use the external memory effectively. And these external memory solutions also add significant architectural complexity, cost, and more potential failure points to an already fragile system. It makes them less robust than you'd want for production. And as if that wasn't enough, there are memory poisoning vulnerabilities. Malicious actors can inject bad data into an agent's memory, creating this persistent contamination that can skew its future decisions across multiple sessions. That's a huge security risk.
Okay, so even if they could somehow remember everything perfectly and reason flawlessly, can they actually connect to the real world, like the actual systems that run a business? It sounds like integration might be another massive barrier, no matter how smart the agent is internally.
That's another major barrier, absolutely. And it's often an underappreciated one. A sophisticated AI agent, doesn't matter how intelligent, is of little practical value if it can't effectively connect with and manipulate the multitude of systems that actually run a business. Most enterprises, especially the large established ones, they operate on this complex tapestry of legacy systems built decades ago, sometimes before the internet was even a big thing. And these old systems frequently lack the modern, well-documented application programming interfaces APIs that you need for seamless, automated integration with cutting-edge AI.
Right, so it's like trying to plug a new device into an old socket.
Exactly. It creates this fundamental incompatibility. Furthermore, data, the lifeblood of any AI system, is typically fragmented across countless data silos within an organization. Departments don't share, systems don't talk, and the data itself is often inconsistent, incomplete, or just plain inaccurate. This magnifies that notorious garbage in, garbage out problem. If an agent gets fed poor quality data from just one silo, it can lead to this cascading series of errors throughout its entire workflow. Now, you can use middleware solutions to try and bridge this gap, act as a kind of translator between the modern AI and the older systems. But that just introduces another layer of complexity, cost, and, you guessed it, potential failure points into an already fragile architecture. It's like adding more adapters and translators to your already complicated tech setup. More things to break, more things to maintain. The crucial point here, and our sources really emphasize this, is that success with AI agents is actually less about building the theoretical best agent and much more about making the enterprise agent ready.
So preparing the ground first.
Precisely. An agent's effectiveness is ultimately constrained by the environment it operates in. Deploying a powerful, intelligent agent into an organization that has messy data and brittle legacy systems. It's kind of like putting a Formula One engine into a horse-drawn cart.
Doesn't matter how good the engine is.
Right. The power of the agent is rendered totally irrelevant by the limitations of the infrastructure around it. Therefore, a truly successful agent strategy isn't primarily an AI project. It's actually a foundational IT and data governance project. It requires significant upfront investment in things like API modernization, beta cleansing, breaking down those organizational data silos before you can expect any real value from the agents. It's about building a solid road for that Formula One car to actually drive on.
So what does all this mean when these agents actually hit the real world? When these technical limits meet actual operational demands? Well, the results can be quite public and sometimes spectacularly embarrassing. Our sources document this whole series of high-profile failures that really highlight the gap between the promises and the actual, often frustrating performance out in the wild. And these aren't just minor glitches. These are instances where the AI went significantly off the rails, impacting customers, damaging company reputations, and sometimes even leading to legal battles. Think about some of these examples. Some of them went viral for all the wrong reasons. First, remember the McDonald's IBM Watson drive-thru? McDonald's ended its 3-year partnership with IBM after these viral videos showed the AI making just bizarre errors. It famously added like 260 chicken nuggets to orders, completely ignored customer corrections, leading to widespread amusement, but also frustration. Imagine ordering a burger and fries, and the AI insists on adding enough nuggets to feed a small village.
Yeah, I remember seeing those videos. Hilarious, but also worry you.
Exactly. The whole thing ended with a complete system rollback, significant cost, and a very public admission of failure. It really showed the danger of deploying an agent before it's ready for complex human interaction. Then there was Air Canada's chatbot. They faced actual legal consequences when their chatbot gave incorrect bereavement fare info to a customer. This misinformation led to a court ordering them to pay, I think it was $812 CAD in damages. And it established this legal precedent that companies are liable for AI misinformation, even from a bot.
So you can't just blame the bot?
Nope. The blame the bot defense didn't work. It had real legal and financial repercussions. And remember the DPD customer service chatbot, the delivery company. Their chatbot started generating profanity and even criticized the company itself.
Oh, yeah. That was after those prompt injection attacks, right?
Exactly. They had to shut it down temporarily. Huge social media embarrassment, a PR nightmare. It just highlighted how easily these systems can be manipulated if they're not properly secured, turning a help tool into, well, a rogue agent.
Yeah.
And the healthcare sector isn't immune either. IBM Watson Health, with this huge, ambitious initiative, employed 7,000 people at its peak, massive investment, but it needed a staggering $4 billion write-off. Why? Because it fundamentally failed to integrate effectively with real hospital systems and deliver on its promises for clinical decision support.
$4 billion. That's colossal.
It was a colossal financial and strategic misstep. It really underscored the challenges of bringing even advanced AI into these complex, highly regulated, very human-centric environments. Even Google, a leader in AI, ran into major challenges. Their diabetic retinopathy screening AI, when they deployed it in the real world in Thailand, it ended up rejecting 21% of the images as unsuitable. And its performance was significantly worse compared to the controlled lab settings.
Right. The real world is messy.
Exactly. It showed how much real-world variability, things like camera quality, patient eye movements, lighting, can degrade performance, even for a seemingly well-designed AI. Lab success just doesn't always translate, and the stakes can be surprisingly high even in software development, which seems like a prime area for AI. Replit's AI agent reportedly deleted a whole production database, over 2,400 records gone, and it violated explicit code freeze instructions. Imagine the panic.
Oof. That's a nightmare scenario for any dev team.
Absolutely. And there was another documented case with an AI coding assistant called Cursor. It actually led to security breaches and database corruption. These aren't minor bugs. They're critical system failures with direct business impact. It proves that even in seemingly contained digital spaces, autonomous agents can still wreak havoc if not properly managed. And finally, what about just general customer service? The front line for so many businesses. Gartner surveys show this significant, kind of alarming trend. 64% of customers actually prefer companies not use AI for customer service.
Really? Why is that?
Primarily, they fear difficulty reaching a human agent when the AI inevitably struggles or gets stuck. And business deployments are consistently showing only about 30–35% success rates on multi-step tasks. That's way, way below the 95% plus accuracy often claimed in marketing materials.
Wow. 35% success versus 95% claim, that's a huge gap.
It is. It suggests widespread user dissatisfaction that really undercuts the whole promise of efficiency and better customer experience through AI agents. It seems people would rather wait for a human than deal with a frequently failing bot.
And what's fascinating here is how all these failures really underscore what analysts call the high-performance chasm. It's that wide, deep gap between the enthusiastic marketing promises and the actual measurable performance you get in messy real-world environments. It's the moment the shiny new toy breaks under real pressure. Gartner analysts, for instance, they estimate that a substantial 40% of AI agent projects will actually be canceled by 2027.
40% canceled. That's huge.
It is, and it's not due to lack of interest. It's because of escalating costs, unclear business value once they get past the demo stage, or just inadequate risk controls. It signals a really difficult period of reckoning for many companies that jumped on the agent bandwagon too early. Gartner also has this very sobering estimation. Out of the thousands of claimed AI agents on the market, they reckon only about 130 are genuinely agentic systems.
Only 130 out of thousands.
Yeah. With most vendors engaging in that agent washing, we talked about just rebranding existing tools like basic chatbots or RPA without adding substantial new autonomous capabilities. This whole phenomenon places AI agents firmly at that peak of inflated expectations on Gartner's hype cycle, which strongly suggests that a trough of disillusionment isn't just possible, it's probably imminent. As the reality of these deployment challenges really sinks in, the industry will likely face this period of recalibration, where the practical limitations become painfully clear. And that could lead to widespread disappointment if expectations aren't managed much more proactively.
Okay, so if we connect this to the bigger picture then, the challenges with AI agents clearly go far beyond just technical glitches or operational missteps. As these systems become more autonomous, making decisions, taking actions, they raise these profound ethical, legal, and societal questions. Questions that, frankly, we as a society are just starting to grapple with. It really begs the question. Who is responsible when an AI agent makes a mistake that causes real harm? Our existing legal frameworks, our societal norms, they just weren't designed for truly autonomous entities operating out there in complex human environments.
Indeed. That accountability void is a particularly significant issue. It's incredibly thorny. When an AI agent makes a decision or takes an action, figuring out who's accountable if something goes wrong is really, really difficult. First, you've got the black box problem. The internal decision-making processes of many advanced AI models are just opaque. They're not easily interpretable by humans. So if an agent makes a harmful error, say, in a medical diagnosis or a financial trade, it can be exceedingly difficult to trace the root cause, which complicates traditional legal ideas like negligence or defect.
It's like a car crash, but you can't tell if it was the manufacturer, the software, or the driver.
Exactly that analogy. And responsibility gets spread across this long, complex chain of actors. The AI model developers, the company that fine-tuned it, the provider of the training data, the developers of the specific agent application, maybe even the end user who deployed it. Whose fault is it?
It's a mess.
It is. This ambiguity creates significant legal and financial risk for everyone involved. And it leads to what some are calling a moral crumple zone.
Moral crumple zone.
Yeah, imagine being the human operator who's forced to take the blame for the failures of these complex autonomous systems that they didn't truly control, maybe didn't even fully understand. That's the crumple zone. The human takes the hit. Existing product liability laws, they're just ill-equipped for this. And while new regulations like the EU AI Act are emerging, they're still in flux, still grappling with how to define and assign liability for AI-driven outcomes. It's a completely new legal frontier we're only just starting to navigate.
Right. And with all the sensitive data, these agents need access to function. I mean, emails, financials, proprietary company documents, what about privacy and security? Surely this opens up huge new vulnerabilities for individuals and businesses.
A critical concern. Absolutely. No question. To do these personalized, complex tasks, agents need deep, persistent access to sensitive data. And that creates this unprecedented potential for surveillance, profiling, misuse of information. Our sources highlight a really troubling lack of transparency and proactive safety measures from developers in this space. It's moving so fast. Fewer than 20% of developers apparently disclose formal safety policies for their agents, and fewer than 10% report any external safety evaluations.
That's not reassuring.
Not at all. It suggests a significant gap in responsible development practices, leaving many systems potentially quite vulnerable. And this deep access also introduces new, sophisticated attack vectors, like those prompt injection attacks we mentioned with the DPD bot. That's a critical threat where malicious actors can embed hidden instructions within the data an agent consumes, maybe hidden on a web page, in an email, even in a PDF it reads. A successful injection can effectively hijack the agent, force it to follow the attacker's commands, leak sensitive data, make unauthorized purchases, even spread the attack to other agents if they're networked.
Wow, so the agent itself becomes the weapon.
Effectively, yes. A compromised agent with extensive permissions can act just like a malicious insider, using its legitimate credentials to steal vast amounts of data without setting off traditional security alarms. And perhaps more alarming, agents could even be weaponized for large-scale synthetic identity fraud. Mass-generating thousands of fake identities, complete with credible-looking fake documents, to create fraudulent accounts for financial crime or disinformation campaigns. It's really a new frontier for cybercrime, powered by AI.
Okay, so what does this mean for our jobs? If these agents are so capable of automating tasks, is widespread job displacement a real threat? Or is it maybe more nuanced than that?
Well, the impact on the labor market is definitely a huge societal consideration. And yes, it's certainly more nuanced than a simple AI takes all jobs story, but the disruption will be substantial, make no mistake. Projections vary, of course, but a consensus seems to be forming. Estimates suggest AI could affect up to half of all entry-level white-collar positions and potentially displace hundreds of millions of full-time jobs globally over the next decade.
Hundreds of millions.
That's what some projections indicate. Jobs characterized by routine, repetitive information processing, think administrative support, data entry, basic accounting, frontline customer service, those are most immediately at risk. AI can just perform those tasks faster and cheaper. But beyond just the numbers, there's this profound challenge some call career path collapse.
Career path collapse.
Yeah. Historically, junior professionals built their expertise by doing the foundational entry-level tasks, the very tasks that are now prime candidates for automation. So if these apprenticeship tasks disappear, it raises a critical question. How will the next generation of senior strategists, architects, leaders, how will they develop their skills? It necessitates a complete rethinking of workforce training, professional development, moving beyond just reskilling to creating entirely new models for building expertise in a world where that foundational work is increasingly done by AI. Experts are urging a balanced approach. Use agents to augment human workers, not simply replace them. Focus on the human skills machines still struggle with complex problem-solving, strategic thinking, creativity, emotional intelligence. The goal should be to elevate human roles, not just eliminate them.
Right. And if these agents are designed to be so autonomous, do we risk losing control? Is there a point where human oversight just becomes impossible or ineffective, leading to, unforeseen consequences?
Yes. That's the fundamental tension. And it's a key part of what's being called the governance squeeze. While agents are designed precisely to reduce human intervention, that's their whole value proposition, fully removing oversight can be incredibly dangerous. Agents, as they currently exist, they lack moral judgment. They lack understanding of context beyond what they were explicitly trained for. If you give them too much autonomy, they might execute actions that are logically optimal to them, but socially or ethically unacceptable, or just disastrous in a real-world scenario. They don't intrinsically know right from wrong or understand nuanced human values. And this is where that governance squeeze comes in. It refers to this inherent paradox. The more autonomous and powerful an AI agent becomes, the more stringent the regulatory and ethical governance you need to ensure its safety and accountability.
So more power needs more rules.
Exactly. But that increased governance, in turn, often constrains the agent's autonomy. It creates a point of diminishing returns. To meet strict governance requirements, things like mandatory documentation, high-quality data, explainability, rigorous human oversight, developers have to build more sophisticated, costly layers of defense and oversight into the agent architectures. This adds complexity, increases costs for computation and maintenance, and can actually reduce the very speed and autonomy that made the agents attractive in the first place. It squeezes the benefits. And existing legal frameworks, often ill-equipped. The EU AI Act, for example, primarily covers conventional AI, but struggles to fully address agents with truly independent decision-making. Cross-jurisdictional complexity is another nightmare. Agents operate globally, but regulations are often national. It creates huge compliance headaches. In regulated or high-stakes industries, healthcare, finance the need for transparency, accountability, risk mitigation. It will almost certainly limit AI agents to a semi-autonomous co-pilot role for the foreseeable future, which directly contradicts that marketing hype of fully autonomous, unsupervised systems. Because human-in-the-loop overrides and rigorous validation become absolutely mandatory.
Okay, so it's not all doom and gloom and catastrophic failures then. Despite these pretty significant limitations and concerns, AI agents are actually finding realistic and valuable applications right now. This is where the practical innovation is happening, and it's fascinating to see how companies are actually leveraging them successfully. What stands out to you about where they're actually delivering? And how are they being deployed without, causing chaos? It seems like the key is often keeping them focused on specific, well-defined tasks, right? Not giving them free rein.
Exactly. What's truly fascinating here is that the most successful deployments, as our sources clearly show, are not in those fully autonomous, open-ended scenarios. No way. They're in specific, narrowly defined tasks. And crucially, they often operate in a human-in-the-loop or assistive capacity. They augment human capabilities rather than fully replacing them. This controlled autonomy seems to be the sweet spot for current AI agent tech. It lets businesses harness their power while mitigating those significant risks we've discussed. Let's look at a few sectors where this is already making a tangible difference. First up, customer support and service. This is a big one. Use cases. Here, agents are proving invaluable for handling routine stuff, FAQs, troubleshooting common issues. It frees up human agents for the more complex interactions. Expert speaker. Imagine, you're trying to figure out why your phone bill is high. Instead of a frustrating phone tree, maybe a chatbot like Intercom Spin instantly pulls up your usage, compares it to your plan, points out a forgotten subscription in seconds, resolves it autonomously. Expert speaker. They're also highly effective at triaging and routing incoming support tickets, making sure requests get categorized right and sent to the correct human or automated system. Expert speaker. Plus, they can process returns and claims, automating that tedious back and forth and providing 24/7 support globally. Expert speaker. Our sources mention Intercom's Fin chatbot, powered by GPT-4 and others, autonomously handling the majority of customer queries by pulling info from knowledge bases and crafting helpful replies. And support AI agents have reportedly increased issue resolution by about 14% per hour on average due to these efficiencies. Deployment. So these systems use LLMs to understand diverse customer language, grab info from knowledge bases, and critically escalate complex or sensitive issues to human agents when needed. The best setups use a hybrid approach. AI handles what it can, flags anything tricky for a human, allowing human agents to focus on the nuanced, empathetic, or complex problems needing human judgment. It's not replacement, it's making human agents way more efficient.
Okay, so agents for customer service makes sense. What about for building the very software they run on? Software engineering has lots of repetitive, critical tasks. Seems like a natural fit for AI help, but I'd still be nervous about a fully autonomous coding agent given some of those failures we talked about.
Absolutely. And you're right to be cautious. Software engineering and IT automation is another significant area, but almost universally in a co-pilot role. Use cases. This includes things like code completion and generation, tools like GitHub Copilot suggesting lines of code, even whole functions as developers type, speeding things up dramatically. Expert speaker. There's also automated code refactoring and reviews. Experimental agents like Facebook's SWE agent are even being developed to find and fix bugs autonomously, basically debugging code before a human even sees it, which is pretty amazing if it works reliably. Expert speaker. Plus, agents are being used for IT operations, monitoring, analyzing logs, alerts, maybe proactively resolving incidents or scaling resources to prevent outages. And finally, helping with documentation and QA generation, grafting doc strings, usage examples, unit tests, saving engineering teams countless hours, deployment. But primarily, these are deployed as co-pilots or assistants. They augment developer productivity, handling boilerplate, analyzing code, generating tests. Developers might be 20–50% more productive on routine coding with AI help, according to some reports. But the human remains firmly in charge.
So the human still checks the work.
Always. Humans oversee, review, validate the AI's output for correctness, design, tricky edge cases, ensuring creativity, complex problem solving, and ultimate accountability stay with the human engineer. It's about supercharging the human, not replacing them.
And in healthcare, where the stakes are incredibly high, how are agents being used responsibly there? That balance between innovation and patient safety must be paramount.
Indeed it is. Balancing innovation and safety is absolutely critical in healthcare, and AI agents are being deployed with extreme caution, primarily in assistive roles. Use cases. One major application is clinical documentation. Agents can listen to doctor-patient visits with consent, obviously, and automatically draft clinical notes or summaries. This massively reduces the paperwork burden. Expert speaker. Doctors spend, what, up to 2 hours on paperwork for every 1 hour of patient care? So AI note takers can drastically cut that, freeing up time for actual patient interaction. Expert speaker. They also help with appointment scheduling, patient outreach, automating reminders, triaging requests. In decision support and diagnostics, they can synthesize vast amounts of patient data and medical knowledge to suggest diagnoses or flag abnormalities. Expert speaker. But it's crucial to understand these are decision support tools, not autonomous diagnosticians. The AI provides info, the human makes the final critical call.
So it's an assistant, not the doctor.
Exactly. And they also help with healthcare operations, medical coding, billing, hospital logistics, streamlining those complex admin processes, deployment. So assisting professionals, reducing paperwork, streamlining admin, providing synthesized info. But critically, all AI actions are subject to strict human oversight and validation due to the high stakes and regulations. Bodies like the FDA treat these as decision support tools. A licensed professional must verify and accept the AI's output. Ultimate responsibility stays human. It's about empowering medical pros, not replacing their expertise or judgment.
Okay, I have to admit, I'm still a bit surprised to see finance and banking on this success list. Given how tightly regulated and risk-averse that sector usually is,
Yeah.
it feels like a fit for automation, sure, but also one where tiny mistakes could cost millions.
Yeah.
How are they managing that risk when others are failing so spectacularly?
That's a very perceptive point, and it probably speaks to the structured way finance often approaches new technology. They have to be careful. Indeed, finance and banking, with their huge data volumes, strict regulations, and demand for accuracy, they present fertile ground for AI agents. But yes, always with significant human oversight and robust validation. Use cases. This includes those ubiquitous customer service bots handling basic inquiries and transactions, deflecting calls, providing 24/7 support. They're also used heavily for Know Your Customer, KYC, and onboarding, automating ID verification, risk scoring, background checks, speeding up account openings, expert speaker. Fraud detection and anti-money laundering, AM, are huge areas. AI agents continuously scan billions of transactions for suspicious patterns. JP Morgan, for example, analyzes vast amounts of data to significantly improve detection rates and flag illicit activity. Expert speaker. Agents also offer trading and investment support, parsing news, analyzing sentiment, drafting reports, augmenting human traders and analysts. And finally, report generation and analysis, ingesting large financial datasets to draft reports, credit memos, summarize analyst notes, speeding up decision-making. Deployment. So handling data-intensive tasks, compliance checks, customer interactions to improve efficiency, consistency. But due to the high regulation, AI agent decisions almost always require human approval. They're built into hybrid models where humans verify AI suggestions. Expert speaker. Our sources note that in some cases, these agents are starting to take on roles similar to junior analysts or clerks, automating the routine parts while humans focus on strategy, complex decisions, client relationships. Expert speaker. And interestingly, companies like Salesforce are even implementing outcome-based pricing, charging, say, $2 per conversation for Agent Force or Intercom charging 99 cents per resolution. It shows a shift towards value-based pricing tied to agent productivity, not just selling software licenses. Expert speaker. Hashtag #6. Expert consensus and the path forward.
Okay, so the overall message from the experts seems to be, while there's real promise, the current reality demands a much more measured, pragmatic approach. It's definitely not the instant revolution the marketing teams are sometimes selling. What's the overarching sentiment among the leading AI researchers and industry analysts as they try to cut through all that hype?
Well, they present a pretty stark counterpoint to that widespread marketing optimism. They're urging a serious dose of realism. Gartner, as we've mentioned, gives a particularly sobering outlook, estimating that significant 40% of AI agent projects will likely fail within 2 years. And again, that's due to rising costs, unclear business value, or insufficient risk controls. It really highlights that high performance chasm we've been exploring. It's a tough truth for companies who maybe invested heavily based just on the promises. They also point to that widespread agent washing, estimating only that tiny fraction, maybe 130 out of thousands claimed, are genuinely agentic systems, meaning much of what's marketed is essentially overpromising what the tech can currently deliver reliably. And beyond the market analysts, leading AI researchers themselves express some fundamental reservations about the current trajectory. You have Turing Award winner Jan LeCun, chief AI scientist at Meta. He flatly states there's absolutely no way that autoregressive LLMs will reach human-level intelligence.
Well, that's blunt.
It is. And he goes further, predicting current LLM-based agents will be largely obsolete within 5 years. This isn't just pessimism. It's a critical assessment that current LLMs, which basically work by predicting the next word, fundamentally lack the underlying cognitive architectures needed for true, robust intelligence and independent action. He strongly advocates for entirely new architectures beyond this basic mechanism. Then you have another Turing laureate, Yoshua Bengio. He raises critical safety concerns, warning about potential self-preservation and deception tendencies in agents if they're unconstrained. He emphasizes the urgent need for trustworthy and safe-by-design AI, suggesting pure autonomy without very stringent safeguards could lead to unintended, maybe even dangerous outcomes. These aren't minor critiques. They're fundamental challenges to the very foundation of current AI agent development, coming directly from some of the brightest minds in the field.
Wow. Okay. So it's definitely not just about building bigger and bigger LLMs in. It really sounds like we might need a completely different approach to get to that true agent capability everyone's talking about.
Precisely. The consensus among many researchers is that merely prompting LLMs in a loop, which is kind of the state of the art for most agents today, is likely a dead end for achieving truly robust and general intelligence. LLMs are phenomenal at pattern matching, generating text, sure, but they lack that deep causal understanding, persistent memory beyond the context window, true planning abilities. So researchers are actively exploring cognitive architectures. These try to combine the strengths of neural networks for perception, language, with symbolic reasoning, explicit memory modules, sophisticated planning algorithms. This hybrid approach aims to mimic human cognition more closely, allowing agents to maintain persistent knowledge, reason over abstractions, learn from fewer examples. The understanding is really that an agent is only as good as the underlying model, meaning fundamental improvements in the base LLMs themselves, better reasoning, longer context, factual accuracy are far more critical for agent performance than just clever frameworks layered on top. And a recurring, really powerful theme from both researchers and practitioners is the indispensable importance of human-in-the-loop design.
Right. Keeping humans involved.
Exactly. Hybrid approaches with human oversight are consistently found to be far more effective than fully hands-off ones. Many experts now argue the near-term future of autonomous agents will still involve a lot of human oversight and collaboration. Humans will keep setting high-level goals, providing crucial feedback, intervening when agents get stuck, ensuring the quality and ethical alignment of the outputs. Completely removing humans isn't just risky, it's often less effective, as those real-world user experiences have shown. It's about augmenting human capability, not outright replacement. Think less robotic takeover, more like a highly intelligent but still fallible co-pilot.
That makes a lot of sense. So given this more measured outlook, what does it mean for the next year or two? What can we realistically expect to see from AI agents in the short term? Consider these pretty significant challenges.
Yeah, for the short term, say the next 1-2 years, expect more of a reality check and continued refinement of what we have, rather than some sudden leap to full autonomy. Specialized and vertical agents. We'll definitely see a shift towards domain-specific agents. Instead of one agent trying to do everything, the focus will be on agents highly tuned for specific industries or functions, like a legal GPT for contracts or a CHIM GPT for research. These vertical agents can embed deep domain knowledge and specialized tools, making them much more effective in their niche than a generic one. They deliver ROI faster because their scope is narrower, more predictable. Embedded and integrated agents. Agent capabilities will increasingly be built right into the software you already use. Think Microsoft Copilot in Office, assisting with tasks directly in context. This lowers the barrier to adoption, grounds the agents in concrete, familiar uses, and allows more oversight as their actions are confined within a known application. You won't launch a standalone agent. It'll be an intelligent feature within your existing tools. Human-agent collaboration frameworks. Expect more formal patterns for human-AI teamwork. Better user interfaces showing an agent's chain of thought so you can see how it's reasoning and letting users easily intervene, correct course, pause agents. Tools like Agent GPT are already moving this way. Human in the loop will just be a standard design principle for enterprise use. Humans orchestrating teams of specialized AI agents, like a project manager. Model improvements. The underlying LLMs will keep getting better, rapidly. Expect models with longer context windows, significantly lower hallucination rates, better instruction following. All that directly enhances agent performance. Multimodal models will advance too, letting agents understand and generate images, videos, broadening their use in design, content creation, etc. Open source ecosystems. The growth of powerful open source LLMs like Meta's Llama models will reduce dependency on expensive proprietary APIs. This lowers costs, enables more customization, allows for on-premises deployment, crucial for sensitive data, and further democratizes agent development beyond just big tech. Regulatory and best practice developments. Regulators and industry groups will release more concrete guidelines. Companies will adopt standardized best practices for agent governance, model validation, bias testing, incident response plans. This professionalization will build greater trust and comfort for responsible AI agent integration, moving us towards more mature, predictable deployment.
That sounds like a much more pragmatic and frankly actionable roadmap. But looking further out then, what does the crystal ball show for AI agents long term, say 5 years and beyond? What's the ultimate vision, even if it's still largely theoretical and needs those fundamental breakthroughs?
Yeah, the long-term outlook, 5 years plus, that's where the vision of truly general, reliable autonomy resides. Though, again, it remains a long-term ambition needing fundamental research breakthroughs. Hybrid cognitive architectures. This is likely the path forward, moving beyond current LLMs to systems combining neural networks with symbolic reasoning, explicit memory, advanced planning algorithms. Imagine systems with distinct modules for different cognitive functions, planning, memory, reasoning working together, aiming to mimic human cognition more closely. Allowing agents to reason over abstractions, learn from fewer examples, maintain persistent knowledge. This is widely seen as the pathway towards artificial general intelligence, AGI, though timelines for AGI, they vary wildly among experts. Multi-agent ecosystems. We'll likely see a shift from single agents to swarms or societies of agents, multiple specialized AIs collaborating, maybe even constructively competing to solve complex problems. This could evolve into complex AI ecosystems, maybe virtual companies managed by higher-level AIs or humans scaling complex tasks through parallelism. Imagine a digital project team of specialized AI agents, embodied agents, and physical interaction. More AI agents will act directly in the physical world. Advanced robots in warehouses, deliveries, maybe elder care. More sophisticated autonomous vehicles. These embodied agents bring extra challenges. Real-time sensors, safety-critical decisions, learning from physical feedback. We might also see augmented reality AR agents in smart glasses, seeing what you see, offering real-time help about your physical surroundings. Blurring the lines between digital and physical. Stronger regulations and ethical frameworks. Society will likely impose increasingly strict governance, maybe international agreements on AI safety standards like we have for aviation or nuclear tech. Formal certification processes for critical AI systems like drug approvals. A continuous strong focus on aligning AI goals with human values. It's possible some uses, like autonomous weapons, might even be prohibited by international consensus as the ethics become too concerning. Economic and labor transitions. The impact on the labor market will be immense. Some jobs transform or disappear, new ones emerge. Needing proactive policies for reskilling, maybe even new economic models to manage the societal shifts. The idea of an AI agent as a coworker will become normal. Individuals might even have personal AI agents managing parts of their lives, scheduling, finances.
That vision is truly expansive, almost sci-fi in places. So what's holding us back from those really transformative long-term visions? What are the fundamental breakthroughs still needed for AI agents to actually reach that next level of general reliable autonomy?
Well, our sources pretty much agree that fundamental advances are required across several key areas to bridge that gap. First, memory. We need robust, long-term memory architectures, ones that let agents learn cumulatively, building on experience without that catastrophic forgetting, developing sophisticated systems for storage, retrieval, summarization, maybe even intelligent forgetting of old stuff, mimicking a human brain over a lifetime. Second, reasoning. We need true causal understanding, not just pattern matching, developing capabilities for complex planning, robust error detection, and crucially, self-correction. So agents can know when they're wrong and adapt their plans, like a human revises a strategy after a setback. Third, trustworthiness. A significant reduction in hallucinations is absolutely essential, plus improved factuality, more transparent decision-making processes, all needed to build user trust and ensure reliability in high-stakes areas like healthcare or finance. Without trust, adoption will always be limited. Fourth, energy efficiency. Training and running these powerful agents is astronomically expensive and energy-intensive right now. We need more efficient algorithms, more efficient hardware to make powerful agents widely deployable without unsustainable costs or environmental impact. Current computational demands are just too high for pervasive, always-on agents. And finally, human interface research. Even if agents become incredibly smart, humans need better ways to understand them, direct them, collaborate with them. Designing transparent AI that can explain its decisions in understandable terms, that's an ongoing challenge, but critical as agents get more complex and autonomous. Building systems humans can intuitively work with, not just command. So our sources conclude that 2025, it may indeed prove pivotal for AI agents, but maybe not as the year they revolutionize business operations across the board. More profoundly, perhaps, is the year the industry chooses. Between continued hype-driven deployment potentially leading to widespread disillusionment and the foundational, often unglamorous, but absolutely necessary work required for sustainable, reliable, and ultimately transformative progress. It feels like a moment of truth where the focus really needs to shift decisively from just dazzling demos to robust real-world engineering and responsible governance. Hashtag tag outro.
Wow, what a deep dive that was. We've really journeyed from those soaring promises of autonomous AI agents, this picture of imminent, transformative automation, industry titans declaring 2025 the breakthrough year, market projections shooting for the stars. But then, beneath that marketing sizzle, as our sources so starkly revealed, lies this incredibly complex reality. Significant technical limitations, from frankly crippling failure rates on real-world tasks, memory bottlenecks hindering long-term learning, fragile reasoning, to that incredibly difficult challenge of just integrating with existing enterprise systems. We've heard about the very public, sometimes painful real-world deployment failures, McDonald's nuggets, Air Canada's legal bill, and we navigated those profound ethical and societal questions, bias, accountability, the potential for significant job displacement. Yet it's definitely not all grim news. We also highlighted specific industries, specific use cases where AI agents are finding realistic and immense value right now, often as powerful co-pilots that augment human capabilities rather than fully replacing them. The key takeaway from the experts seems to be this resounding call for a more measured, pragmatic approach, focusing on foundational improvements, memory, reasoning, trustworthiness, along with robust governance and seamless human-AI collaboration. The future, it seems, isn't about fully autonomous AI CEOs anytime soon. It's more likely about specialized, embedded agents working intelligently alongside humans to tackle well-defined problems, elevating our own capabilities in the process. So as you navigate the claims of new AI systems, as you consider their potential impact on your work, your business, maybe even just your daily life, consider not just what they promise to do, but also how they'll recover when they inevitably go wrong. Because they will. And crucially, ask yourself, what level of human oversight will truly be needed to make them trustworthy, effective, and responsible in your world? What stands out to you about that delicate, constantly evolving balance between AI autonomy and human accountability in the coming years?